Hey everyone, this is a short video to show you around epiPath, the completely in-browser image annotation, dataset creation, and zero-cost AI inference engine we've developed for digital medical imaging applications. The URL to this web application is episphere.github.io/path. This will also be available as a link in the description, so if you want to try it out in your own browser, please feel free to do so. And yeah, let's get started. So when you visit the application for the very first time, you'll see this interface. It's fairly empty. There's just a placeholder of an image right now. And the reason for that is that the tool relies heavily on cloud storage services for much of its functionality. And these services, like Box for example, need you to log in. So if you have a Box account, click on the login to Box button. You might have to enter your username and password and go through the whole flow. I've already done that. So let me just click on grant access. And you see the application already recognizes me based on my Box login, and it asks me to select a dataset. Now let me come back to what a dataset is in the context of epiPath, so I'll skip this for now. But as you can see, I have access to all the files and folders in my Box account right from the web interface over here. That's because Box allows authenticated applications to be able to act on behalf of the user and convert any action that the user makes into what's called an API request, wait for the response from Box, and then render it in a fashion that the user would appreciate. So for instance, if I were to click on this folder, epipath_demo over here, the application asks Box to return all the files present in that folder. Now if I were to select an image file from here, the application asks Box for the image, shows it to me on the left here, and I can also select one of the thumbnails, and it works the same way. So the application essentially acts as an intermediary between me and Box. Now this folder over here is essentially a raw data set because all of these images are unlabeled. There is no way I can train a supervised machine learning model on these images without adding labels to them first. So the way I would do that is by going to the annotations tab and creating a classification definition. But right now, as you can see, it's grayed out, it's disabled. And the reason for that is because epiPath does not have a place to store the definition that you create. What you need to do to add such a place is to create a data set out of this folder. So let me go ahead and do that. The way I'd achieve this is by going to the name of the folder and clicking on the three dots icon against it and selecting the user's dataset option. When I do that, epiPath in the background is setting up all the configuration files it needs to use this folder as a dataset to allow me to add annotation definitions. We can see it's done. Add AI models that I train based on those definitions. So once it's done, we can see the add classifications button is now enabled. I'll click on that, and let me just try creating one annotation for us. Add a description. Let's enable comments, and we have categorical labels for now. And these are the labels that we'll add to the individual images. Let's keep it simple, good and bad maybe. The value can be the same as the name, or it can be anything you like. So let me make it 1 and 0 and create a class. Now this class has been created and we can use it to assign labels to all these images. This class is part of the dataset configuration. So an added advantage of this is that despite the fact that this folder has been created by me and only I have access to it right now, if I were to share it with anyone else in Box, they would automatically also have access to these annotation definitions. If they come to the tool, they would also see this classification option available for them directly. So that's quite handy. Now, because we have the classification definition ready, we can start annotating these images. Based on some subjective criterion I have for this classification, I'll just select this image as good. Maybe this image is not that great, I'll call it bad. And these annotations, once again, because the application does not have a backend or a database to store them in, it again leverages Box's APIs to sort of memorize them. So when you select an annotation over here, it is telling Box that this image has been classified as good. Box then goes and stores it in what's called the file metadata. And whenever the application comes back, for instance, if I refresh, even though I haven't stored them in my browser, the application can just ask Box for those annotations back. So this image was good, this image was good as well, this image was bad. So that's how the application has memory despite not storing anything locally. Once we've done that, the next step would be to just go ahead and label enough images in this data set that we can train a neural network model to learn this classification for. So let me go ahead and do that. So I've done that. I've annotated all of these images for good or bad. And the next thing I'm going to do is extract these annotations as a manifest file, as a CSV, and then use Google's Cloud Auto ML service to train a neural network model out of it. So let me just do that and I'll be back again. So model training on the images that I just classified is complete. You can see the model score and the prediction being assigned right here. Let me refresh the page to show you that the model is being loaded in the browser. You'll see a message pop up that says, yeah, loading AI model. And this model is again part of this dataset. All the files that correspond to the model are inside this dataset folder. So again, anyone who has access to this folder also has access to the model. The model has been loaded. So let's try it out on a new annotation. Yeah, you see, the model score is right there. Now, because the model is in the same place as the image, one big advantage is it's quite fast. And the second one is that the data doesn't need to go anywhere. So there's no chance of data being compromised at all. So yeah, we can see the neural network is doing fairly well. This was not such a good image according to my criterion, and it does agree with that. So there we have it. That's epiPath. If you guys have any questions, any issues, if you face using it, please go to the issues link over here. It'll take you to GitHub issues, and you can create your own issues. Let me know the problems that you're facing. If you want to see the code, it's open source on GitHub. That is also accessible from the application, and we also have a Gitters channel that we use for conversation. If you want to join in, that'd be great. So yeah, that's it. That's epiPath. Hope you guys have no problems using it, and let me know if you do. Thanks a lot.